Welcome back to Principles of Technology. This is going to be lab 1.3. It is voltage and measuring voltage sources. So one thing you're going to learn in this lab is you're going to first off learn how to connect a simple series circuit. You are also going to be able to measure voltages in both direct current and alternating current series circuits. And hopefully we get around to observing the voltages add up in a series circuit. All right, first off, as far as materials goes, you are going to need a couple of these components here on this electrical mounted component section of your lab table. We are going to use 3 different resistors, and they are color coded. So there will be a way to a chart or a diagram on how to read these color coded resistors right here. So these are resistors. We will need 3 of these throughout the lab. We will also need a knife switch, and it's labeled there for you. Essentially that's coming off the electrical components. Moving on over, one thing we do need is a circuit board, and the great thing about the circuit board is, you know, there's no need to be tying and twisting around wires anymore. These circuits, the circuit board is already kind of set up and an ideal circuit board for what we're trying to use it for. This is called a circuit board easel, and a lot of people don't know that, you know, these can separate from each other. But there's also a little section where you can keep a couple of your components. This white piece allows some contrast so you know what you're working on and where you're putting things. So you will need that. Moving on over, this lab does require that you strip some pieces of wire. So you would take a simple wire stripper, cut yourself some wire, and then use a stripper to peel back some of the, expose some of the metal conductive wire inside of that. So you will need to do that eventually. So you will need the strippers and some wire. You also need 2 different kinds of leads. One of the leads I'm going to use is essentially a basic plug-in lead that is identical on both sides. So I'll have a red and a black lead. And you know, red and black are used to just really in most of these labs just to be able to figure out which lead you're actually working with, just giving it color coding and giving you a little more simplified way of figuring out what each one is for. In addition to those leads, there's also some other leads that, you know, are the plug type, and then we have a wire lead at the end right here that will plug into your easel once you need to. So those are your leads that you're going to need. Those are found in your universal lead set. Moving on to the last bit of equipment right here, you know, both these little components look exactly alike. The great thing for you guys is it is labeled. This is a high current power supply. So essentially there's 110 volts coming through the wall, and this allows you to work with electricity in a safe manner. So you're able to regulate the voltage that you're working with this power supply. It's going to be connected into the wall. It's a little heavy. It also has various functions right here. I could use direct current, alternating current with different voltages, and likewise with the other ones. Most of the settings we're going to use are DC and AC. There is a power button, and then there's a knob to adjust the voltage that you're going to use. So just understand what we're doing is taking the voltage from the wall. We're gonna kind of decrease the voltage enough so that it's safe for you to work in the classroom. So there's your power source. Now, whenever you got this power source, you want to take a couple different measurements of things, and this is what this component is for. It's called a multimeter. The multimeter can measure current, it can measure some resistance, and then it can also measure what we're kind of seeking out is voltage. So just kind of think about it this way. This is a supplier of your voltage. This is a reader of your voltage for this lab. So we will mainly be using only this side because this is reserved for current. All right, so most of the stuff we're going to be using are these 2 little panels right here. All right, so like I said in this lab, what we're going to be doing is providing voltage through a series circuit. So the very first part of this lab is going to run you through just checking to see that this is actually providing some kind of voltage, and that this multimeter can actually make voltage readings. So pretty simple. I got my components shut off. The power's off, and I'm going to go ahead and start connecting this. Now remember, we're going to work with voltage. So I'll take one of my leads, color-coded black, into my multimeter, and I'll run it over, and I'm going to the AC/DC voltage adjuster in my power supply. I'll do the same thing for my red lead. Connect that and connect that. So we know that this is providing the voltage. This is going to read the voltage that this is providing. One little point here is that we will not use anything greater than 15 volts. So I went ahead and took my voltage adjustment knob, and I'm going to set it to 15 volts. You kind of want to take a pretty good guess of what your voltage is going to be and just be right above that. After that, what I really want to make sure is that for this experiment, I'm using DC voltage, and that's represented DCV. So I got the DC voltage pressed. I also have my power supply all the way counterclockwise to make sure I start off on 0 voltage. And then I'm also saying my power supply should supply 0 to 24 volts DC before I even start. So pretty simple setup. What I'm going to do is I'm going to turn on my power supply, and I'm going to turn on my multimeter. Now, one thing about this is my power supply is saying it's providing 0 volts of 0 voltage. So I want to make sure that my multimeter is going to read 0 volts. And it's a pretty tricky thing to read this on this analog multimeter. But where you want to read is right above that red writing right there, that 0. That first 0 you run into, that's the scale we're going to be looking at. So one thing about that scale is if I got my power supply set at 0, then my multimeter should read 0. So we have a 0 adjustment knob on this multimeter. And so if I were to plug in my power supply and I know that I have 0 volts, well, I would want to make sure that my multimeter is going to read 0 volts. So I could take this 0 adjust knob, make sure I adjust it to 0. And I know that from now on it's going to read my voltage. So I'll take my power supply, I'm going to slowly increase the voltage, and I will stop at right around 6 volts. So at this point I know that my power supply is supposedly providing 6 volts of electricity, and if I were to take a reading on the multimeter, it will read 0.6 on that scale that was given to me there. The reason for the scale being off by a factor of 10 is something we'll talk about in class. So the first part of this lab is going to require that you use some resistors. These are 3 resistors I pulled off the resistor storage board. Now, how you would read these resistors is all in the colored bands right here. Gold, as far as I know, I always hold on the right-hand side to give this kind of a direction. So gold is always on the right-hand side, and I'll just read it like I'm reading a book. I'll go color-wise, I'll go brown, black, red. So pretty simple. I'll come over to my chart and I'll say, all right, we had a brown band, so that's a 1, followed by a black band, that's a 0. So far I'm working with 10. Now the third band is red, and the third band is going to essentially tell me how many factors of 10 I should include with my number 10 that I already have. So 10 times 10 to the second would give me a resistance of 1,000. So this is your 1,000 ohm resistor. And if you were to read through this one, this would be your 2,000 ohm resistor. You do have a red, which is 2, a black, which is 0, so that's your 20. And then we should increase that by a factor of 10 2 times. So 20 times 10 to the second would be 2,000 ohms. You will also need your knife switch. And in this setup, what you want to do is go ahead and ensure that your knife switch is on the circuit panel, and you want to press that down and make sure it snaps into the metal connectors. I will take 2 of my resistors for this first part, and I am going to connect them along the same line as my knife switch. Now the knife switch has these poles, these metal conductive poles on them that are snapping into the circuit board. So once I got that in there, I got to make sure that my resistors are on that same line that those poles are on. So I'm going to use this same exact line to connect my resistors to that knife switch. And here comes another one. And essentially, whenever you connect these resistors on here, you want to make sure that you have a little bit of room to connect our one resistor to the next resistor, and that's where your little piece of wire comes in handy. I'm going to go ahead and connect one section of my wire over that other section, and now I know that this is now connected to that one. In addition to that, what I could do is have another piece of wire and give myself a little more space to work with right here. And since I have that piece of wire, I'm going to do that. Right here it goes. And now we have a simple circuit setup. We have a nice switch that will open and close the circuit. And all we need to do now is provide some kind of power to the circuit. So I'll take you back to your power supply. And what I'm going to do is go ahead and power up this circuit. I'll open the knife switch. And I've left this on DC voltage as well. So I got my knife switch open. And so now I'm assuming that there's power being supplied to the circuit. And if you remember one thing, what we're trying to do is just, check to see if there is some kind of power through the circuit. So a couple of measurements you're going to make is you're going to make a voltage measurement across each one of these resistors. You're going to make a voltage measurement across these resistors.